Um, so what we have to remember about the inverse function is that if we have, say, a function which is like this, and the inverse function would be like this. They are basically symmetrical with regard to the line y equal x. We've seen that in previous lessons. So if I say I want to look at the derivative at that point, which is the slope at that point, well, so the derivative at the point opposite to it here would be like this. And what we can see is that the slope for the blue line is the reciprocal of the slope for the red line. So this is written like that. dy over dx is equal to 1 over dx over dy, because dx over dy represent the slope for the red line, whereas dy over dx represents the slope for the blue line. Now we can also demonstrate that algebraically by writing it like this. D over dx of y is equal to d over dx of f of x. Now, using the chain rule, this is the same than d over dy, my apologies, d over dy of x of y is the same than d over dy of f of x, which is d over dx of f of x times d of x of dy. This is the chain rule. And this is dy over dx, and this is equal to 1. So therefore, dy over dx is equal to 1 over dx over dy. Right, so whichever method you prefer, that's the end result. Now let's move to the differential of inverse trig functions. So sine minus 1 of x is defined for x between minus 1 and 1. So so therefore x is, so if we have y equals sine minus 1, so that means that x is equal to sine x, and where y is between minus pi on 2 and pi on 2. Okay, so dx over dy over dy is equal, well, the derivative of sine is cosine, so cosine x. And so therefore, using what I've done above, dy over dx is equal to 1 over cosine y. And here we must have cosine y must be different of 0. And y is between, so actually y is strictly between pi on 2 and minus pi on 2. So that means that because so if we look at the unit circle, pi on 2 and minus pi on 2, so unit circle is like this. So we are either in the first quadrant or in the fourth quadrant, minus pi on 2 plus pi on 2. That means that cosine y is positive. Okay, so we can reorganize that a little bit. Dy over dx is equal to 1 over plus or minus root of 1 minus sine square y. But we know that cosine y is positive. And sorry, that comes from the fact that cosine square y plus sine square y is equal to 1. But we know that cosine y is positive because we are in the first or fourth quadrant, so therefore dy over dx is not plus or minus, but it's 1 over root of 1 minus sine square y, and sine y is equal to x, so therefore it's 1 over root of 1 minus x squared. So here we go. So this is, what we wrote to be dy over d over dx of sine minus 1 of x. Now, this formula is in the formula sheet. Yep. Okay. Let's slight variation. If we want to do d over dx of sine minus 1 of x on a, where a is a real number, difference of 0, of course. So, okay. So that's 1 over root of 1 minus x on a square times the derivative of what's inside, which is 1 over a. Can we simplify that? Yes, a little bit. So it's a root of 1 minus x on a square. So, okay, we can bring the a inside. So that becomes 1 over root of a square minus a square times x square over a square, which therefore let's rewrite it. D over dx of sine minus 1 of x on a is equal to 1 over, simplified, 1 over a square minus x square. Right. Cosine minus 1. So we just proceed exactly the same way than what we did with sine. So let's write it y equal cosine minus 1 of x. And this is for x between 1, no, for minus 1, no, cosine x, what's that, y. Okay, so that means that x is between pi and 0. So therefore x is equal to cosine y, and so if we do dx over dy, the derivative of cosine is minus sine, and so so therefore dy over dx is equal to minus 1 over sine x, and we can transform that a little bit. Dy over dx is equal to minus 1 over plus or minus root of 1 minus cosine square y, which is minus 1 over plus or minus root of 1 minus x squared. But so sine y, x is between 0 and pi, so therefore sine y is positive. So that means that we can eliminate the minus here, so it's just equal to minus 1 over root of 1 minus x squared. Formula which is in the formula sheet. Now, if I have, let's change color, if I have y equal cosine minus 1 of x on a, where a is a real number different of 0, where dy over dx is equal to minus 1 over root of 1 minus x on a square times the derivative of what's inside. There's a chain rule. Okay, so we can simplify that. 1 over root of a square minus x square. Let's do a quick example. If we have, say, y equal cosine minus 1 of 2x plus 1, the derivative dx over dy would be minus 1 over root of 1 minus 2x plus 1 square times the derivative of what's inside, 2. And we could maybe simplify that a little bit, can we? Yes. Minus 2 over root of 1 minus 4x squared minus 4x minus 1. Okay, yes, indeed. So that's dy over dx is equal to minus 2 over root of 4 times 4x times minus x minus 1. Yep. Okay, tangent. So y equal tangent minus 1 of x, so x is equal to tangent y, and dx over dy is equal to the derivative of tangent is secant square, so secant square y, so therefore dy over dx is equal to 1 over secant square y. Now, using the Pythagorean relationship of the unit circle, I'm just going to do that again here. We have the unit circle, we have here theta, and here we have the tangent, so this value here is tangent theta, and this is secant theta here, from here to here. So therefore secant square theta is equal to 1, because this is 1, this is the 1 square plus tangent square. So therefore, therefore secant square is equal to 1 plus tangent square, so it's 1 over 1 plus tangent square y, and tangent y is x, so therefore dy over dx is equal to 1 over 1 plus x square. This one is also in the formula sheet. And little application, so say, okay, so now if we have y equal tangent minus 1 of x on a, where a is a real number different of 0, so dy over dx would be 1 over 1 plus x on a square times the derivative of what's inside, which is a. So therefore it would be equal to 1 on a plus x square on a, which can reorganize if we time both the numerator and denominator by a as a over x squared plus x squared. I'm going to do just one example. Okay, let's differentiate. Let's problem that is recurrent. Sine minus 1 of x plus cosine minus 1 of x, f of x. So f prime of x is equals derivative of sine minus 1 is 1 over root of 1 minus x squared, as demonstrated above, and the derivative of cosine is minus 1 of root of 1 minus x squared. Okay, so they cancel each other, so it's equal to 0. What does that say about f? Well, if f prime is equal to 0, that means that f of x must be a constant, because otherwise the derivative, for the derivative to be 0, it has to be a constant. So what is the value of f of x then? Well, we just pick a value at random, say for x equals 0, for x equals 0, f of 0 is equal to what? Sine minus 1 of 0 plus cosine minus 1 of 0. Sine minus 1 of 0 is 0. Cosine minus 1 of 0 is equal to 1. Is equal to pi on 2. And so therefore, f of x, which is sine minus 1 of x plus cosine minus 1 of x, is equal to pi on 2 for all x. And that's it.